Hello friends, this is Mohammed Shakil here, and in this tutorial I will show you how to create a non-structural hexagonal nut firstly, then insert parameters to relate to the dimension constraints, then create a design table with the current values, edit and insert additional configurations in the design table, thereby to reflect it in the model in various configurations, create a power copy for the bolt, which is very important, and use the bolt power copy to instantiate in different documents at any given time, and later on, lastly, to create a catalog and instantly resolve all nut configuration models as different CAD part files in a different folder. So this is the dimension of the nut, and this is the representation, and we're going to use the non-structural bolt. So let's start off with the design. Firstly, go to new and go for a new part and name it as nut study. And firstly, we'll create the basic nut design. So go for a sketch and create a sketch. So you need to see something here. So firstly, in the geometric set, make sure that you have defined inwork object for the geometric set and rename it as input, and then create a point for that. Come for the wireframe and surface design and go for the point and create a point here. Make sure that the point is a datum point, so we don't have any parents or children for this point. Even if you check, it won't be there. And then create a dummy XY plane. So just copy this plane and paste it here, paste special as result, and rename it as XY plane, and select the YZ plane, copy it and paste it special, and rename it as YZ plane, and then hide the original planes and come to the part body and rename it as the nut, and make sure that you have this defined inwork object. And let's start off with the basic sketching. So firstly, go for the sketch and select the XY plane and go for the profile toolbar. In the profile toolbar, select the hexagon. And one more thing, when you're selecting the sketch, alright, let's just go ahead, I'll talk about it later. So come to the sketch, make sure that you have selected the XY plane for the sketch, and create the hexagon, and make sure that you have coincided the point with it. And then you can see the diameter over here is the D value. So firstly, just come out of the sketch and go for the parameter or the formula, and click on your parameter of type and write it as D, the diameter, and specify it as maybe 12. Okay, and add few more values, maybe one more, and that's the S, E, and M. So S value, and just go for the, just let it be like that, and go for another one, E again, no, So again, another one, and that should be SE and M. So let's go for M and click on apply, click on OK. So we have the diameter and 3 other different values, which is understood from the drawing, and we're going to relate the D with these values. So S is 1.60. So click on S, edit formula, that is equals 1.6 multiplied by D. Click on OK. That's done. Now 1.68D. E is 1.8D and M is 0.8D. Edit formula, 1.8 multiplied by D, and the next value is, what was that, 0.8D. So let's just check. Alright, values are correct. 1.6, 1.8 and 0.8. Now we have to relate these parameters into the sketch. So let's see how we can do that. Come into the sketch, and now the diameter. So insert another circle here, and just make it as radius. Go for edit formula, click on D divided by 2. So that's the first one. Now here's another thing that you need to be careful about. Pull this down, go down, pull this closer. Alright, now this value is E, so you need to edit formula. This value is E. Now we got that E value. Now let's see the S value. We have to insert the S value now. So as the design is already fully constrained, I don't think you can insert another parameter inside this. So maybe I think we could the 0.6. Let me see. That's the D value. First value is done. Next value is 1.6D. That's the S value. This value. Okay, we have inserted the E value now. S value and M value is remaining. Value is yet to come. So S value is what we need to insert. So that's a problem here. So if we try to insert, it's 18.7, 19.2. So it doesn't match. That would be a problem. So as of now, what we'll do is we will delete. Okay, we will remove this. Okay, we'll come out of the sketch and we will remove this particular parameter from it, and now our design makes sense. Now we need to add this as our thickness for the nut. So for that, go for the pad, come back to the pad and click on the pad, and here go for edit formula, and here the M value, and that's it. Now we need another plane, and we need the plane to be aligned with this, so that means we need the ZX plane, if I'm not wrong. Yeah, we need the ZX plane. So let's do one thing. Let's copy this and paste it here and rename it as the ZX plane, and delete the YZ plane because we don't need it. So XY and ZX plane, and just make sure that you're hiding this. Now we need to add another sketch. So first we'll add a sketch here, and we'll create a circle, and we will dimension coincide tangency. Yes, yeah. Okay, now come out of the sketch. Now we have the sketch over here, and this sketch will be referenced in order to create the what do you call the chamfer. So if we directly apply the chamfer here, it's not going to be the exact whatever chamfer you can see in the nut. So this is the way you can create the chamfer on the nut. So let's see how we can do that. Come for the sketch and click on the ZX plane, and then use the project 3D elements and click here and select that particular line that you created and use the dotted lines. Now come for the line and make sure that's not dotted, and click on this, and again come back to the normal view. Now you can give a 30-degree angle. And there is another trick that you need to use over here. So it's basically that you can do one thing. You can use this command and just extend this, and now use this line as well and extend it, and from here just use a line which is vertical, and then again use this line and just connect it. Lastly, you could trim this portion. Now come out of the sketch, and now you could use the slot function for this, and you need to create an axis. So for doing that, what you could do is come back to the generated shape design workbench and create line, point direction. The point should be this one, and Z component. Just give something, doesn't matter. Just make sure that your datum is not on, because we need a parent function for that. Now again, come back to the Power Design workbench, and now use the sketch and go for the groove and select the line as the axis and click on OK, and we got the slot. Now hide this sketch and just rename this line as the groove axis, and hide groove axis, and we have created the nut. Now the next thing what you need to do, let's see. So the first part is over. Now the second part is also over. That's the insertion of parameters. The third is to create a design table with the current values. So let's do that. Go for the design table, create a design table with current parameter values. That's good for us. Click on OK and go for the user parameters and select 3 of them and click over here and click OK. So we've created the parameters. Click on desktop tutorials and go for 325 and nut config should be okay. Click on OK. So that created conflicts between this design table and the relations. You can either remove. Okay, let me just do that again. So these two parameters are actually driven by the diameter, so we don't need to insert these two values inside the design table. So go for the relations, because already a design table is created which is deactivated. Let me delete that and again come back to the design table and create from the current parameter values, and in this user parameters and select only D, and rename, overwrite it. So that does our work. Now we got D12, that's diameter 12. Now if we edit the table, and you need to insert another column called as part number, and okay, let's say let me insert 14, 16, 20, 24. Okay, this much is enough for as of now. And here the part number, so nut, so equals to concatenate. Now M space, and again then B12, B2, good, then comma, then nut. That's it. Good. So here, okay, just a nut space M12 nut. Okay, that's good. So between M and 12 there need not be a space, so just M12 nut. Alright, that's good. Now if we drag this down, it's M14, 16, 20. So concatenate just takes the value from here to this one. So let me save this and close. And if I just wait for some time, then the synchronization is done and we have the different configurations being loaded to the design table in Catia. Now if I click on OK, now if I just wait and come to the design table, just rename the design table table as not configurations. I'll just double click on it and select maybe a 16 and click on OK. So the design changes and I find there is a problem with the design. So what could be that problem? Let's come back to the previous configuration and let's resolve that problem. There is something that I haven't. R6. Okay, so I haven't related this value. So if I see E value is not related, so double click on this, edit formula, and just apply the E value, click on OK. Now exit the sketch. Now if you come to the nut configuration, if I apply 16, oh, doesn't change. So that's interesting. Still the formula is not applied, so edit formula, so that's the E value is applied here. OK and OK. Exit the sketch. Okay, now it's applied. Now I'll just try again, maybe at 12. Okay, that's good. At 20, that's good. Okay, so that's the design table is applied now. I'm sorry that I sometimes make some mistakes. I think everybody makes mistakes when we are designing something. We forget some aspects. So now let's see, edit and insert additional configuration in the design table, thereby to reflect in the model. Okay, we have already done that. So let's just in the edit table we have an option here, and we can give the 18. I've missed the 18, so I'll just put 18. Right, 18 is added. Now if I click on save, close, you can see that that value is being added. Now if I double click and if I select 18, click on OK, and the configuration changes to M18 nut. So that's how the design table works. And again, now let's come back and let's see. Create a power copy for the bolt. Let's see how we can do that. So for creating that, let's come back and I'll select parameters, relations, and the nut. Okay, go for insert. Oh, where am I? Okay, parameters, relations, and nut. Go for insert, knowledge templates, and power copy. And now you can see XY plane, point, and this ZX plane are our inputs, and these are our outputs. Now click on OK. That creates a power copy here. Now we need to replace or rename the power copy. Rename it as the nut underscore PWC. In fact, our call of prayer is going on, so let me just pause this video and I'll continue it after the call of the prayer. Now that the nut power copy is created, now we can instantiate the nut power copy in different documents at different point of time. All we need is just a point and 2 planes. That's it. And all the different aspects we have created here is going to come. So let's just save this in the nut study. Okay, save it. Now we save it as a power copy. Now let's just let me show you how this power copy works. So go for the part, click on OK, and see, in the geometric set, all I'm inserting is just a point. So okay, so X, Y, and Z explain, copy. Well, that's not required. Just a point is required. Just go here and create a point anywhere. It doesn't mean that it should be in the center. So for example, we are creating a whole design here and we need a nut there. So we'll just create a point where the center has to be, and then what we'll do is just go for insert, and instantiate from document, and possible to instantiate. Okay, so that document has to be closed. So now this document is open, that's why we are not able to instantiate. So I'll just close it and I'll come back again and instantiate it. This time it gets instantiated. So XY and the point is here, and the Z explain, and click on OK, and the nut is instantiated. Congratulations. So as I've shown you before, if I change the configuration is not going to change. So we can use this nut n number of times in n number of documents however we want. That's one thing. Now let me close this. I don't need to save it. I'll just come back to my previous. Okay, this is what we are. This is where we are now. So I've created the power copy, used the bold power copy to instantiate in different documents at any given time. Now the last thing is to create a catalog and instantly resolve all nut configuration models as different CAPA files in a different folder. So that means that we have these number of configurations. Okay, so let's say we need these different configurations to be saved in a particular folder. So without we manually inserting, going to a new file and creating a point and inserting, it's a tedious task. Instead of that, we're gonna, maybe for example we have hundreds or 1,000 configurations. We can just go and we can insert this in the catalog and do it easily. So let's see how we can do that. Go for the new file and go for a catalog. Where's a catalog? Okay, a catalog document. Okay, now go for insert, part family, select the document, and 325. Okay, click on OK, and we have the part family here. So before doing that, just go here in the options and change it to this particular resolved. I'll just insert resolved PWC just to recognize, and I'll just take this path and I'll insert that path here. Click on OK, and I'll just make sure that path is being copied. Yeah, it's copied. Now let's come here and go for resolve. So let's check out that folder again, and you can see all this configuration is being resolved, and that completes our 7th part of our tutorial. So that completes our this episode of tutorial. I hope you enjoyed this, and this is a little bit lengthy video, but I hope this video is going to help you a lot in your projects, and I hope you'll come back with different questions. And I definitely need your support. I need you to subscribe to my channel. I want your all of your viewers to share this video and make my channel to reach to different levels. So I hope you enjoy, and I'm enjoying creating videos for you guys. Thank you so much, and stay tuned.